Okay, boys and girls, welcome to lesson 6-6. Here are the two warm-up problems. You guys should do this stuff and we'll check them when you get back to class tomorrow. Again, you'll be good with this. You guys got plenty of skill. All right, 6-6, the official lesson that we're talking about, folks, is being able to solve systems of inequalities by graphing. So we're going to talk about the situations that are modeled by this, and then we're just going to show you two examples. Now I have simplified the two examples so that you get the gist of the information. Your actual assignment will be much more difficult as you'll have more steps to get it into kind of like a slope-intercept form. So a system of inequalities is a set of two or more inequalities with the same variables. So in example 1 we have y is equal to a 2x plus 2 and y is greater than or equal to a negative x minus 3. So your first step, even though that it's already been done for you in these examples today, is to put your equations into slope-intercept form with the fact that it's going to have, instead of an equal sign, one of our inequalities. And then we'll just graph the two separate situations and see what happens here. So here is the first graph. Now I have the luxury of using different colors. I would suggest to you that you do the same exact thing if you can. Otherwise you're going to have to draw lines a little bit differently. So y is less than a 2x plus 2. We go up 2 to graph our y-intercept and then a slope of 2. So that's up 2 over 1 and down 2 to the left 1. Now what we're going to do here, folks, is we're going to have this because it's just a less than sign. We have our dashed line. So I've pretty much already created the dashed line the way you can see it, and my own body is in the way of me being able to continue on there, but we'll change that later, I guess. I'll just put an arrow here. Now I'm going to change colors, and I'm going to actually I need to stick with this one. Y is less than, so we're going to shade on this side, the underneath part of our line, because y is less than y, the variable y, everything less than it is underneath because it's on the y-axis. Now we'll switch colors. That was a little bit too soon there. Now with this next problem we have y is greater than or equal to a negative x minus 3. Same exact thing, we'll just graph it onto our coordinate plane. We're going to go down 3 from the origin. 1, 2, 3. That is our y-intercept, and we have a slope of a negative 1. So a slope of a negative 1, going down 1, right 1, and we'll be going up 1, left 1 to get the opposite of that. And now this is an or equal to, so we're going to want to connect the dots. So this has to be a solid line because of the or equal to. Now because y is greater than, we shade everything above. And now you guys hopefully are seeing that there's an area where there's an overlapping part where both lines are being shaded. So I'm going to take another color here and I'm going to make that very, very clear that this is the area that both of our inequalities have a true statement. So I could pick a point that's in this shaded area and I would solve for our system of inequalities. So if I pick just this point right here, that's going to be a solution to our system of inequalities. There's going to be an infinite number of solutions when we solve systems of inequalities, or there could be no solutions whatsoever. Every single time we have this shaded area where they overlap, folks, we are looking at an infinite number of points that are going to make this situation true. All right, moving forward. Next example. Same exact kind of a process here. I'll choose the same colors even. Y is greater than or equal to a negative 3x plus 1. We'll go up 1, then we have a slope of negative 3, down 1, 2, 3, to the right 1, down 1, 2, 3, to the right 1, down 1, 2, 3, to the right 1, and then we'll do the opposite, up 3, to the left 1, up 3, to the left 1, up 3 to the left, and it's a or equal to, which means that we're going to have ourselves a solid line. It's a pretty good line for me sketching here, and we're shading above because it says y is greater than. Now y is greater than up here. And I'm using a vertical line, and on the next one I'll use a horizontal line so that we can see where the lines crisscross easier for the shading part of it. Hopefully they shade. Maybe they won't. Y is less than or equal to a negative 3x minus 2 on the next one. Minus 2 is our point. Oh, it's the same slope. Same slope tells me that I'm going to have either all solutions or no solutions. 1, 2, 3, to the left 1, to the left 1, to the left 1, to the left 1. And it's again a or equal to, therefore I have a solid line. I don't know why my black line needs to come out. Forgot to get all of that. There we go. And our red line is where y is less than, so y is less than it below. So that's this side. And you can see that they are going to never intersect. So that means the solutions are going to be no. We just got interrupted by a student, but that's okay. You guys should understand that I am in my classroom. But again, no solutions because they don't overlap our shading areas. So we're looking for where do these shadings overlap to have our solutions. Now again, like I said at the very beginning, these are the easiest possible examples. You will be forced into on your assignment and on your test and everything else in the world to create them into a slope-intercept form. So this isn't going to be most of the time just this simple. All right, folks, that's all we have for today. I wish you the best of luck. This is the last lesson of Chapter 6, so now we're getting prepared for the test. This is Burmination. We're signing off.